So today the topic is on the engineering solution of ASD in cold storage area. So this is the topics will be covered in this webinar, including the introduction. Then we will take a look on the risk, cost, and also the damage. Then we will go through all the challenges with the low temperature. Then we look at the application scenario, and then from our side, we have our design recommendation and the guideline. Then on the sixth item, we will look at what are the general mounting and installation method. Then at the last but not least is the commissioning of the system. Okay, so warehouse and storage facility are being constructed to meet the increasing demand from the urban population growth. So with the increasing of population, there are more storage warehouse to store all the goods that we need for daily and also for long-term storage. So with the change of consumer behavior, we are also innovating the goods and service fulfillment to serve the customer better. So with the rapidly growing e-commerce and also digitalization of warehouses, cold storages cater for increasing preference for usually the fresh and frozen perishable goods, pre-packed or grocery shopping, pharmaceuticals, and also biological component. And nowadays, we are not able to miss out the high-value electronic goods. So in this topic, I will use the refrigerated storage and cold storage interchangeably, but of course, there are slight difference in terms of the specific name based on the temperature. Now we look at the general cold chain product storage temperature ranges. So for deep freeze, usually it is rated at -28 to 30 degrees Celsius. This is especially designed for seafood and meat storage. Then we see the second temperature range is for the frozen, usually for meat, which is ready to be transport for transport purposes and also retailing. Then the chilled temperature is from 2 to 4 degrees Celsius. Usually this temperature is for the dairy products, fruits and also vegetables, and fresh meat as well. Then for pharmaceutical line, we have temperature range from 2 to 8 degrees Celsius. Okay, we come into this topic during the COVID days because the vaccine need to be stored at a specific temperature to retain its efficiency. Then we see also the cold chain for the processed food or over-the-counter medication, which will be rated from 12 to 14 degrees Celsius. So the purpose of this design guide is to provide the recommendation for cold storages, including the large commercial cold storage. You see the picture on the right top. We have a very big commercial cold storage, and inside this storage, usually you have a high racking system. Okay, so this high bay racking will be housing all the pallets, bulk goods, and etc. So usually, this kind of large commercial cold storage will have an increased level of automated configuration, and also it has very narrow aisles in the rack. Then on the bottom, we see a small box-in box or modular walk-in cooler, which is ready for those smaller factory or warehouses. Maybe only a section of the factory or warehouses is equipped with this box-in box to store the specific material. we look at the risk, cost, and damage now. So inside a cold storage or any warehouse, usually you have full packaging material, which is easily combustible. For example, those wooden pallets and also the carton boxes. So inside the warehouse, you also have the conveyor belt and also forklifts. They might pose a risk or fire risk in this kind of environment. So we look at one of the case study in Frigo Cold Storage in 2010. The source of ignition is the spark of welding, developed to a full-blown fire during the weekend. So it took 2 weeks to extinguish the fire, and the total damage is more than 68 million euro, and you have to pay almost 500,000 for the firefighting services fee from the authority. And then you lost all the products inside, and you lost also your business operation. So now we have come out, Securiton has come out with a very detailed and extensive guideline, which is called a refrigerated storage in our system. This design guideline covers the codes and standards from FM, CIBA European, CEA for EU nation, and also the FBA in UK region, BIS in India, and also IPENS in New Zealand. We combine the best of the details inside all these codes and standards and come up with our extensive design guideline. You may refer to this guideline coming from us. Then we will share this document to you if you require that. Now, let us look at all those challenges within the cold storage. Usually for cold storage, you have a large open space. So this is very difficult for some service and maintenance job. So we need a centralized point. Maybe if you have an ASD, you have the unit located at the main working height. Then the pipe network will extend to the top of the building or inside the racking. For the ease of service and maintenance, you are only looking at the unit at man's working height. Okay, further to that, in large open space, usually you have some problem with the stratification, where the air becomes denser at low temperature. Okay, so these smoke particle, when they have a stratified problem, then it will not travel up to the ceiling. So you might need to have a vertical sampling point as well. So in this case, we can also design for the in-rack in case if there is any stratification. Following to the stratified problem, inside the cold storage, usually you have very strong air circulation. Okay, inside this area, the smoke dilution is very serious due to the addition of smoke, the fresh air coming in, and then this smoke never reach the point detector within the area, and the inside inside the container with such condition, you might have a sudden pressure changes, which might be a very problematic for ASD pipe airflow circuit. So inside the cold storage, you might have extreme low temperature. You also have the problem of a contraction of expansion of the pipes network. You can see in the picture on the right here, the pipes are all not properly fixed and they do not have the expansion joint. Hence, the pipes are being torn off from the connection. And we also have heavy condensation and ice formation due to the low temperature. And of course, we are not able to do cross coverage sampling point, which means one detector covering two area with different temperature if you are using an ASD system. Okay, if you are familiar with working with cold storage area, and if you are working near the opening of the cold storage or at the entrance, you will see the cold and hot air. This area will have severe water cloud problem. This is due to the water vapor cool to the very low temperature and it form into a fog. So this water vapor cloud will create nuisance alarm and freezing up all the sampling point in this kind of area. So beam and point detector will not be suitable in this kind of environment. Then for low temperature as well, we have limited choice of detector. So most of the detector are not rated to this temperature. For example, the point detector, usually they are working at 0 to 50 degrees. Or some laser-based ASD, they are only rated down to -5 degrees Celsius. And of course, those beam detector, the industrial grade type, rated down to -20, might not work in -30 environment. So we have limited choice of detector. Okay, so those detector that is not rated down to -30 degrees Celsius, they must be mounted outside the refrigerated area. So you have wall penetration, and with this, you can see the cold pipes. The pipes are fogged up with huge ice, and this ice will break the pipe if it gets heavier and heavier. So you need to have frequent maintenance to maintain the system. So coming back to the low temperature as well, if the detector is placed outside and the cold air coming out will cause problem to the ASD, you also need a addition of heating box. Okay, with all this addition equipment, of course it will have extra cost problem, and then the extra component you need to maintain that. So this only reduce the problem of the protection and freezing up of the ASD. You are missing out one of the most important thing in this kind of installation, which is the sampling point. So if you have ice formation clogging up all the sampling point, then it will not have any smoke particle inside the area travel into the sampling point and back to the ASD. So this system is considered a failed system if you do not have a de-icing feature of the sampling point. This is a very serious problem. As we all know, commonly, if the room temperature decrease, the air humidity will decrease drastically, and this reduction of those vapor will come out as condensate. We will see those water vapor that stick to any surface with colder temperature. So this is where all the humidity coming out from the air. So we must know that we must take into consideration the lower temperature is, the lower the humidity. And with lower humidity, all the storage material within the cold storage will become extremely dry, and dry material leads to easy fire. Okay, then for ASD system, if you put them outside, you must have the recirculating pipe available. Okay, and we do not recommend this because you will introduce more penetration to the insulation wall, and it requires specific method to patch up the insulating wall. Okay, then if you look inside of the ASD, if you plan to install the ASD outside, then the cold temperature from the inside will be taken from the ASD into the smoke chamber for analysis of the smoke particles. Then it will be returned back to the room. So if you see those areas where cold air and hot air meet, definitely there will be condensation and also ice formation. This is one of the example if you plan to install them outside the cold storage, then this ice, thin sheet of ice will be formed near the component. So in long run, it will damage the electronic component. Okay, then just now we mentioned about the sampling point without the heating element. So you will clog up all those sampling point and there will be no smoke particle transport back to the ASD for analysis. So in this case, we have the unique solution from Secreton, which is the heater sampling point. So this heater sampling point will automatically heat up the heater element on the sampling point to do all the de-icing. And once the airflow return to normal, it will stop the power of the heating. So it is not operating at all time, and it is also done automatically. Okay, then if you look at the picture here, we have the fan blower of the cold storage area. We shall not place the heater sampling point in front of this cold fan blower. So even the pipes that run just right across this blower shall be protected with a polyethylene foam pipe for insulation. And also you might introduce an aluminum sheet deflector to prevent the extreme fan directly blowing onto the ASD pipe as well. So this is one of the methods to protect the system. Okay, if you look at the diagram below, those small rectangle is the blower, then the pipe that is located right in front of the blower shall be protected with the insulator. Okay, now we look at those areas and we will want to see what are the application classes required. So for storage room, freezer, chiller room, production area or packaging area, you might need class B sensitivity. This is not a mandatory requirement, but it's a recommendation from us. Then for cooler, loading bay, return air path, and also offices area in the refrigerated warehouse, you can use the class D as standard sensitivity. Please be reminded that all the ASD application in cold storage only applicable for general freezer room, but not the shop freezer room. Okay, shop freezer room, you are not able to be protected with ASD due to the heavy ice formation. Okay, this is due to the effect of shop freezer. They rapidly freeze the food to temperature below -18°C in a very, very short period of time, usually within 30 minutes. So the use of shop freezer is to store the food to be stored in weeks and months for bulk purchases. Due to the effect of this freezing, rapid freezing, there will be heavy ice formation and it will not be sufficient for the system to cope with this low temperature attack from the shop freezer. Now we look at the design recommendation with ASD system. Only the 25 mm pipe are permitted to be used. And if you need to use metal tubes, please consult us and we will take a look at the system before we can design with a metal tubing. Then the sampling point shall be equipped with a heating element. The picture on the left here, this is the heated sampling point, especially designed for deep freeze application. Then no sampling clips, sampling point for sealing duct, or sampling stub is allowed in this kind of application. And the sampling point shall be accessible. Okay, you must ensure then it can be accessed easily by a forklift or ladder. Then this sampling pipe and sampling point must be 2 meters away from the lamp, air duct or air outlet opening of the cooling unit. Then for the filter, we will be using the small filter box FBS 25 PC in our ASD system. And the last one will be the installation near the interlocking and also feed opening must be avoided. This is the area where the hot and cold air meet, and it will create a lot of condensation and fog in this kind of situation. Now we look at the system limit when we are designing the ASD in cold storage. So if you are designing with Class A and Class B application in mind, please take note the total length of sampling pipe shall be less than 120 meter for Class A and 140 meter for Class B. Then for Class C, you can go up to 200 meter. Okay, then the max length or the farthest point from the sampling hole, this is the equivalent linear farthest point, which is up to 80 meter. And you can only design up to maximum 10 sampling hole per channel of the ASD. Okay, then if you have bigger warehouse, okay, and you need to extend the total coverage, okay, you have more than 10 sampling points per sensor, you must conform to this extended limit used when you are designing the cold storage. All this design recommendation is stated in our design guideline in details. So in this slide, I'm just sharing a little bit on the topic. And if you need the detailed engineering and also calculation, then please refer back to us and we will guide you with the guideline and also the advice on the design. So this extended limit is for advanced user where you design this heater sampling point with more than 10 units. Okay, if you look at this previously, the limit for the system, you are only allowed to design up to 10 sampling hole per channel, but all these are limited to the capacitor of the relay. So it's not the capacity of the ASD system. So because due to the extra heated sampling point and also the wiring, we need higher power. So all the relay output, the contact is limited with a certain power limiting. So we need to have an external power relay to provide additional power to those heater elements. And with this additional of external devices, we are able to design more than 10 sampling points per channel. In this case, if you look at the diagram here, we have 20 heater sampling points per channel, then the next 20 for the second channel. If you are doing this, it is mandatory to do the design with our ASD pipe flow system. Okay, then please take note, one WCU, I will explain what is a WCU later. This is just a wiring connection unit for the wire to the heated sampling point. So you are only allowing up to 10 sampling point per WCU. Okay, then the additional of power supply, you need to do a detailed current calculation for the overall power requirement. Then this external relay for higher corresponding capacity. Then the additional of WCU and its supply line as well. When you are designing the coverage of sampling point in the warehouse, this is for the spacing and positioning at the ceiling level. So at the ceiling level, you can go up to maximum 10 by 10 meter if you design according to BS standard. And if you go with NFPA, you will make it to about 9.1 meter per sampling point. So you can place them in this 9.1 meter spacing. Then all the points shall be connected with the sampling pipes. So in the horizontal or vertical manner. Then for in-rack protection, okay, those ASD pipe designed within the racking, you will refer to the BS standard. At any rack that is higher than 8 meter, you shall consider the in-rack protection. So it's just a consideration and it's not mandatory. Then those sampling pipe, okay, you will go into the racks at 3 to 8 meter interval. So if you have the rack more than 20-30 meter height, so every 8 meter maximum, you will have one pipe running across the rack, and the next 8 meter you have another pipe running at the inside the racking. Then after you have designed all the sampling point, the location, and also number of pipes, you must calculate the design based on our ASD pipe flow software. So this is a detailed introduction with the design with ASD pipe flow. This is especially important for our business partner that has already signed up with us. Then if you have this kind of design, you can refer to this when you are doing the design of the ASD system pipe flow. For design for cold storage, you will need to change some of the options, okay, within the software to optimize the design. First, you need to change the sampling point to drill type. Then you must select the user-defined hole size. So this heated sampling point has a range from 3 millimeter to 5 millimeter opening. Then you must save everything. Then you can design the pipeline and optimize the calculation to show the sensitivity requirement and also the transport time. So this is an important setting inside the software. Then after you have done the calculation with our pipe flow, you will get a positive result. Okay, it allows the number of sampling point, the sensitivity, and also transport time. Then you will come to the next one, will be the power calculation. So each ASD, the heater sampling point, and also the addition of those relay module card, you must incorporate all the current consumption for this equipment. So for example, you have 4 ASD with a total of 36 heating element or the heater sampling point. So from here, we can see that we assume the maximum current consumption from each ASD is at 500 milliamp. So we have 4 units coming down to 2000 milliamp for 4 number of ASD. Then for the first 30 heater sampling point, each rated at 110 milliamp, we will have 3.3 amp current consumption. Then the additional 6, each at 65 milliamp. Then the total power supply unit for the 4 number of ASD, you will need a minimum 5.7 amp power supply unit. This is just an estimation if we are using a common power supply unit to serve 4 number of ASD. But if you are giving the power supply to each and every ASD, then you just need to calculate the number based on each ASD. So if you have 1 ASD, it will be 500 milliamp. Then maybe for that system, you have only 10 sampling point. So 10 sampling point is approximately 1.1 amp. So total you need about 1.6 amp for each ASD. That is the estimation. Then for the material of sampling type shall be PVC or ABS, but we would like to recommend ABS material for cold storage due to the property of the material. ABS is less fragile when you are using it in this kind of a low temperature. And of course, the mix of PVC and ABS material pipe is not recommended because the glue that glues the PVC and ABS pipe is different material. So you are not able to mix the glue used for connecting the pipe. Then please do not forget that every pipes in the ASD pipe network, we will need to add a CCF, a cable connection fitting. So if you look at the diagram here, the pipe coming up, and we have a T for a branch connection. So inside this pipe, we will have the silicon wire cable. We call it lead wire. We need 2 different colored silicon wire from us. Which is the SLW 0.5 black and also SLW 0.5 white. So this cable is to connect the heated sampling point, and it will be running within the pipe network. So the cable will then terminated on the ASD to control the power supply to the heater element. So every T connection, you need to have a branch of wire as well, right? Then you need the CCF cable connection fitting to do the T connection for the wiring. Okay, if you look at this diagram properly, you will see a T connection, one to the left and one to the right. And each wire will then be connected to the heater element of the heating sampling point. Okay. Then we take a dive into the connection of this silicon wire. So if you have this heating element, the heater sampling point, and on the top you have a cap here. So this you have to unscrew and open up the cap to allow you to have the access to the wire and also the heater connection. So the heater is actually just a resistor to connect at the point here to provide the heat energy to melt the ice. So the wiring coming from the pipe inside will then connected to this connection screw here, and then it will then extend to the next sampling point. So this is the detail where you do all the installation wiring of the heated sampling point. Then all the cable you see on the top left here, the silicon wire will come back to the ASD unit. Before they are being terminated inside the ASD, you will come back to a WCU first. So this WCU, because of the filter unit, okay, on the right below the ASD unit, you have the filter. You are not able to get the cable going through the filter. So this is why we need a WCU unit where it became a junction box for the interchanging from the silicon wire back to connection cable in red color back to the ASD. Okay, so due to the fact that cable cannot go through the filter at the bottom, so we need a WCU here to allow the transition from the pipe to wire back to the ASD unit. Okay. Then on the right here, you will see all kinds of the heated sampling point sizes from 3 mm to 5 mm. And the color sticker on the heated sampling point indicates the opening size in equivalent. So the 3.0 mm will be indicated in red color and then brown color for 5 millimeter. So this WCU is actually just a wiring junction box where the top is the connection to the pipe, then at the bottom is also to the sampling pipe. Then on the left, you have the wiring outlet to connection to the ASD unit. Okay. And if you look at the wiring diagram here, if you have only one connection, WCU, the power supply, we need the power supply to be provided to the heater sampling point. Then if you have enough power supply unit, you can tap the power supply from the motherboard of the ASD and connection to a relay, which is the relay to control the heating element. So as I have explained previously, the heating is not turned on 24 hours. So it's only turned on automatically by the ASD when there is a clog up of ice at the heater sampling point. Hence, you have the lower airflow. Okay, I repeat again. The ASD will automatically turn on the heating based on the airflow reduction. So if the heater sampling point is blocked up by the ice and you have a reduction of airflow, then it will automatically turn on this relay here, the relay 3, to provide the power to the heater sampling point and do all the defrosting function. Then for the diagram on the right, you see the connection for two WCU, which leads to two connection of the pipe network. One is to the first channel, second one is to the second channel. Okay. So prior to commissioning, we also need to measure the combined resistance of all the connected heating resistor. This heating resistor value here will allow you to check whether all the connection to the heater sampling point are correctly terminated and it is not missed out from the connection. So let's say you have 10 sampling point connected to one WCU. When you measure the resistance, okay, at the WCU, you will see approximately 22 ohm due to the parallel connection of the resistance from the heater sampling point. Okay, when you have this reading, which means all the heater sampling point are connected and terminated correctly. Then after you have do all the installation and checking on the heater sampling point value, now we go to the programming of the heating control. from the ASD unit. So to control the ASD, we need a ASD config software. And in this step, you can see that we need to select the relay, the heating control function here. So if you can see on the motherboard, relay 3 now, just 2 minutes ago, the heating control is controlled by the relay 3 in the motherboard if you are using the single channel. But if you are having 2 channel of ASD, you will need an addition of relay module card. So this relay module card allow you to have extra 5 number of relay. Then for first channel of ASD, you can use the relay number 4 to trigger the heating control. Then relay number 5 to trigger the heating control on the channel number 2. So you must program them exclusively in the software. So this relay will serve as the on and off button to the heating control. Then last but not least, in this setting, the heating time can be set from 1 to 60 minutes. So by default, it is set at 2 minutes. So once there is a requirement to turn on the heating, then this heating will take up to 2 minutes, then it will turn off. Once the airflow is returned to normal. Okay. So in general, I mean from the user point of view, we have advantage of the ASD system inside this cold storage protection area is because due to the most reliable and very early detection from ASD system. So we have early warning in high airflow environment and less false alarm and also icing due to the vapor. So this is done by actively sampling the air, and we have a cumulative sampling effect and also automatic de-icing. Then the most efficient serviceable system here will be having the return, higher return during the maintenance. And also the test sampling point can be located outside the cold room for testing purposes. And then unit can be networked and remotely operated as well. So all this will be increasing the efficiency of servicing the system. Then the last one will be a stage incident control. We will have pre-alarms coming from ASD system. So these pre-alarms allow you to have the stage response or staggered response. So maybe at the lower alarm stage, you can start to have an alert for all the operator. Then if it reach the alarm, it will be directly triggering the call direct to the authority, the fire department. And also the last one, after confirmation of the alarm, we will release the extinguishing agent to fight the fire if there is such a suppression system. So we have all these stage alarm directly from the ASD system. Okay, last but not least, we have all the approvals for ASD system. For region in Malaysia, we have the FOMBA. Then for other international region, we have VGS, EOL and FM approval. Then for China, we have CCCF, and Korea, we have KFI approval as well. So, okay, I think that's all from my side. I mean, would you like to share some of the project references in the region?
Just want to share with the audience, some of the project references in the region. Can you help with the clicking? Just some photos to share. So not in Malaysia particularly, but in our neighboring country in Thailand, Lotus, also what we have here in Malaysia. So in Lotus, in this Suratani distribution center, they service, they provide this distribution of goods to the southern region of Thailand. So in here, in this location, we have our ASD system installed in the distribution center. And next one, also popular supermarket over there, also in Thailand, Big C. We have also our Securiton ASD installed in this Wang Noi distribution center. Yeah, thank you. So the key takeaways for today's webinar is aspirating smoke detection is a proven effective method in this challenging cold storage environment. I think we know from Kafei's explanation earlier, due to the high airflow produced by these cooling units, this ventilation providing this newly fresh cool air into the environment of the cold storage, we can't really rely on the conventional point type detectors, for example. So we have this ASD, it's a very proven technology. We have proven successful cases, not just in this region, but all over the world, due to the these heating elements at the sampling points. The second one would be ability to operate from -30 degrees, allowing us to mount our ASD inside the cold storage or the deep freezer together with the sampling networks. So this reduces all the headaches coming from the different temperature extremes of cold, very cold temperature meeting with a warm temperature outside, and it causes a lot of these issues to the ASD, hampering the effectiveness of the ASD to operate, and of course reducing the reliability. So ability to operate together inside the cold environment is a very strong added point. And of course, last but not least, I think this is unique to Securiton. We realize that this is a very challenging application, requiring this special solution. So I think we are I think easily the only one who have this unique heating solution that kicks in the heating when the ASD detector detects a reduction in airflow due to the this formation of ice at the sampling points. Yep. So these are a few key takeaways that we want you to bring back with you today. And of course, finally, we have in this, if you scan this QR code right now with your phone, you can access our libraries of all these design guides, case studies on our website. You just have to go to the website and register for this access to this literature that we have for you. Okay, so this leaves us to the end of the webinar. We are now ready to receive any questions from you. Should you have any questions for us?
Yep, feel free to raise any question to us. And if you have any inquiries, especially for these cold storages, please feel free to email to us. And if you are free, please have a look on our LinkedIn channel or Instagram if possible. So for work, usually we will go to LinkedIn channel and subscribe to us as well. Okay.
I think we'll leave it for around 30 seconds to anticipate any questions from you. So we have a question from Hilt. Can stainless steel be used instead of ABS? Kafei,
Yes.
you want to elaborate?
Yeah. Okay. Definitely yes. Any tube material can be used with our ASD system. Not only limited to stainless steel, we can have a copper tube as well. And if you have those mild steel tube, hot dip galvanized tube, there is any material, but you must conform to the dimension that is required from our ASD system. So for stainless steel, the minimum internal diameter shall be from 19 millimeter and above. So the maximum size for ABS is up to 25 millimeter outer diameter. In actual, the OD shall be approximately 22 millimeter for ABS. But for stainless steel, it will be ID minimum 19 millimeter.
Thank you,
So
Kafei.
stainless steel can be used. PVC is not fire resistant. Okay, yes. Yeah, you're right. PVC is not fire resistant, but ABS, we recommend ABS in this case. So ABS is less, we call it the spreading of fire is less for ABS. So we recommend ABS material for our application. Then we have second question. Can I have your presentation file? Yes, of course. Later, you will send to all the participants, right?
I would say upon request. I mean,
Yeah.
so
Okay.
not yeah, but
I
we
see.
can definitely do that. Yeah.
Yes. Okay. FTE is fire trade.
Okay.
Then the next question for ASD 535-2 can be used for 2 pipe or 2 area different temperature. It's not recommended because when you have one ASD, taking care of the channel 1 at below 0 degrees Celsius, and the second channel with standard room temperature, then inside the ASD will have some cold and warm region. So you might have some condensation happening at the ASD. So that is the reason why we always recommend to place the ASD directly inside the same region, so you do not have the mixture of cold and warm air. So if you introduce the second, because the unit inside the ASD, they are sharing one fan. So the air coming from the first and second channel, they will be mixed together in the fan unit. So it is not recommended for or used in two different temperature zone. Okay. So for the next question, we have any safety mechanism to prevent the possible faulty heater becoming the fire risk itself? ABS by fire source. Oh, okay. No worry about that because the heater is just a small resistor at the point. It has limited wattage to create enough energy to burst into fire. So all these are already pre-designed, and it shall not becoming the fire risk itself. And then the heating is only heated up to 2 minutes by default. So all these are being incorporated as well. Okay. So
Right.
that
Thank you
is
so
very
much for
good.
all the questions. Yeah. Very
Yeah, good response from the audience.
participating audience. Yeah. And thank you so much, Kafei, for your addressing the questions.
All right. So I think, yeah, it's almost high. And if this is in contact, yeah. What I mean?
Yeah, sure. we'll do that. Yeah.
Okay. So thank you
I think
very much.
we have a last slide, right? You can
Everyone.
share the last. Yeah, I think the context. Yeah, these are the contacts
Okay,
that you.
sorry.
Yeah, so these are basically all the people in the ASEAN team, so to speak. So that you have me, Chan here, based in Penang, Malaysia, and we have Theo in Kuala Lumpur, and Niran is our sales and marketing person in Thailand, and Yong, one of the latest addition to the team, based in Ho Chi Minh. And Daniel is our regional manager, and Kaibin, Cafe, and Jess, they are the technical people who can help with the designs, requests, with the drawings. So we rely a lot of them. So
Okay.
please feel free to contact any of us. If you like to also visit us in Sekuriton, Malaysia, in Selangor, please feel free to contact us, make appointment with us. We shall accommodate your visit. So with that, I think we have no more questions. We shall call it a day. Thank you so much once again for joining us today. We'll see you in the next one. Thank you.
You're welcome. Thank you, everyone.